Hello, welcome to Electrical Circuits, part number 15. Today we'll be discussing parallel inductive circuit analysis. This will be a purely inductive circuit. And as you notice, we have our schematic up here so we can trace it. We have one path right here from our power source to a node where we can go to L sub 1, the first inductor, or we can go down here to another node where we have L sub 2, or another path to L sub 3. Coming back through L sub 3, we come through and we have another node where L sub 2 connects in, another node where L sub 1 connects in, back to our power source. So we do have two or more paths for the current to flow. It is parallel. Notice we have 60 hertz, 120 volts. Our inductive reactance at the first one is 226 ohms. At the second inductor is 150, and 188 ohms at our third inductor. So we'll start off our voltage total in a parallel circuit. It remains constant across all branches. So V sub 1 is equal to V sub L1 is equal to V sub L2 is equal to V sub L3, which is equal to 120 volts. So we can populate V sub 1, 2, and 3 with that 120 volts. Now we need to find our total inductive reactance. And we'll use the reciprocal formula, a little bit of a variation on it. It'll be 1 divided by, open our parenthesis, 1 divided by x sub L1 plus 1 divided by x sub L2 plus 1 divided by x sub L3, close our parenthesis. And we populate those x sub L1 with 226 ohms, x sub L2 with 150 ohms, and x sub L3 with 188 ohms. It'll give us 60.93 ohms. Now really in reality we could call that 61 ohms, we could call it 60 ohms, because again our calculations are a baseline that we use to compare, are we in the ballpark. It's kind of like horseshoes, close does count. Now we'll look for our inductances, and so we'll use the formula of we'll have to manipulate the formula we used earlier. So our inductance is equal to our inductive reactance divided by 2 pi times the frequency. So for the first inductor would be L sub 1 is equal to x sub L12 divided by 2 times pi times the frequency of 60 hertz, and x sub L1 was 226, which would give us 599.48 millihenries. X sub L2, or excuse me, L sub 2 is equal to x sub L2 divided by 2 times pi times our frequency is 60 hertz. X sub L2 is 150 ohms. That would come out to be 397.89 millihenries. And L sub 3 is equal to x sub L3 divided by 2 times pi times our frequency is 60 hertz. X sub L3 is 188 ohms, and that would give us 498.69 millihenries. Now we need to find our total inductance, and it's going to be equal to our inductive reactance total divided by 2 times pi times our frequency is 60 hertz. Our total inductance that we calculated earlier, or total inductive reactance that we counted earlier, is 60.93 ohms. And when we plug that in, it gives us 161.62 millihenries for our total inductance of this circuit. Now we're going to look for currents. We're going to use Ohm's law on our currents now. So I sub 1 is equal to V sub 1 divided by L sub 1. So even though our voltage is 120 across all branches, we still want to be specific with which voltage. That way when we switch back and forth between series, parallel, and series, parallel, we don't get confused. We know exactly which voltage we're talking about. So 120 volts divided by the 226 ohms is going to give us 530.97 milliamps at that first inductor. The second inductor, the current at the second inductor would be equal to V sub 2 divided by x sub L2. So 120 volts divided by 150 ohms would give us 800 milliamps. I sub 3 is equal to our voltage at the third inductor divided by the inductive reactance of the third inductor, so 120 volts divided by 188 ohms is going to give us 638.3 milliamps. Now we need our total current. So our total current is I sub t is equal to V sub t divided by X sub LT. We calculated that earlier. So we have 120 volts divided by 60.93 ohms, giving us a total circuit current of 1.97 amps. Now all we have left to do is figure out our VARs. Remember, VARs are wattless power, and so VARs sub L is equal to I times V. So getting very specific, VARs sub L1 is equal to the current at the first inductor times the voltage at the first inductor. So our current at the first inductor is at 530.97 milliamps times the 120 volts. Notice again we take it back to standard decimal notation for our calculations, giving us 63.72 VARs. VARs sub L2 is equal to I sub 2 times V sub 2. So VARs sub L2 is equal to 0.8 times 120 volts equals 96 VARs. VARs sub L3 is equal to I sub 3 times V sub 3. And so our 0.6388 amps times our 120 volts gives us 76.6 VARs. And now we need our total. VARs sub LT is equal to our total current times our total voltage, which will give us 236.4 VARs. Now we have our list of our calculated values. We're ready to go out and measure the current. Are we in the ballpark? Go look somewhere else. If we're way out of the ballpark, off in right field, you need to look at that part of the circuit a little closer. That concludes part 15 of our tutorial series. Thank you.